Welcome to Accelerated Engineering. My name is John, and this is the video encyclopedia entry for the OCT2HEX function, or octal to hexadecimal. Oct2hex is responsible for converting values from octal, or base 8, to hexadecimal, or base 16. For example, we could take the number 5, which is represented in octal, or can be represented in octal, and convert it to hexadecimal, where it is still the number 5. Remembering that octal takes 3 bits and converts it to 1 digit, hexadecimal takes 4 bits and converts it to 1 digit. We need this value to be at least, we need it to be greater than 8. So let's put a couple of digits in here. There we go. Get some of the fun hexadecimal output. 1, 2, E. To confirm what this is doing, or what number this is representing in base 10, which is what we all think about, I'll just plug in a hex to dex conversion here. So, oops, I can't use 9. There we go. We can see that, for example, this is one we can do in our heads. 1, 1, and 1, 8 is equal to 9 in decimal, and equal to 9 in hexadecimal. Because in order to get interesting numbers in hexadecimal, we need to push over the value 9 in decimal, which is to push anywhere beyond 1, 1 in octal. For example, 1, 2 is going to show the value A. It's equal to 10 in decimal, A in hexadecimal, and 1, 2 in octal. So there's a little bit of interesting bits and bytes. Pun intended. Okay. So some limitations of this function are the maximum value that can be input based on Excel's representation of octal numbers. Excel limits its representation of octal numbers to 10 digits. If the first digit has to have a leading 0, the first bit must be a 0 to indicate a positive number. It means that the first number in an octal string is 3. I can now follow that by 9 sevens, filling the remainder of the bits in this number with 1s, and converting this from octal to hexadecimal gives the maximum output of 1 FFFFFF. Okay. In decimal, what is that in decimal? 2 decimal. Show curiosity. There we go. 536,870, 911. The largest value representable. Conversely, the smallest, or the farthest from 0 negative number that can be represented is 4 followed by 9 zeros. There we go. And a better way to think of this is that there is a 1 in the signs place, and the rest of the number is zeros. And this would be a 2's complement representation of a large negative number. In hexadecimal, this is represented this way. Again, with an F at the front, that means that the first bit way up at the front is going to be a 1. And if I convert this from octal to decimal instead, then we get a very small number. Let's make that bigger. There we go. Oh, look, that looks familiar. 536, 870, 912. It's off by 1 because that's, binary. Well, if you like that slightly convoluted explanation, or you enjoyed some of the other function discussions or encyclopedia entries, please consider liking and subscribing, and you can leave a comment on this one to say, oh, John, you butchered that just a little bit. But yeah, this would be a great thing to like and subscribe. It would really help out my channel, especially because I think this is the 12th encyclopedia entry on numerical representation conversions that I've done. It's been a lot of work, but I've kind of enjoyed it. Any which way, there is another argument in the octal to hexadecimal function, and it is places, because Excel represents these with up to 10 digits. I can pad with leading zeros to just kind of fill out my cell a little bit, or to keep things consistent. Oops, I'll have to give it proper numbers. Haha, too large. There we go. Oh, I think I could do better than that. Yeah, that's just fun. All right. Anyway, now that I've had some fun, Related functions to this are the octal to binary and octal to decimal, the rest of the family of the octal conversion functions, and the function that does the opposite, which is hexadecimal to octal, or hex to oct. And this concludes the video encyclopedia entry for the OCT2HEX function. Thanks for watching.